Hi, welcome to our next level 3 videos. In this two videos, we're going to talk about a technique called integration by substitution. Right, straight into examples and let's show you how this technique works. We're going to integrate bracket 2x minus 5 bracket all to the power of 5 with respect to x. Now you could, if you're really interested, expand out the 5 brackets, multiply them all out, use whatever technique you get, and eventually get this polynomial here, which has got a power of 5 in. I'm not in the mood to do that, so I'm going to show you a technique called integration by substitution, which I hope shows you a lot quicker way to do this. All right, we're going to start off and let whatever's inside the brackets be equal to u. U is equal to 2x minus 1. Now, while we're over here doing a little bit of extra work, let's differentiate the u function with respect to x. I know we're doing differentiation in an integration topic, but let's differentiate u to get 2, because the 2x differentiates to 2 and the minus 1 disappears. Now, let's take the du over dx and multiply both sides by dx to get du is equal to 2 times dx. And let's divide both sides by 2, so that we get du over 2 is equal to dx. Or we could just say dx is equal to a half of du. Right, let's come back to our original working and let's do the following changes. Let's replace 2x minus 1 with u. So we're going to substitute this 2x minus 1 in for u. We're not going to use brackets anymore because it's just u to the power of 5. And now let's take the dx and replace it with half du, because we've just worked out over on the side that dx is equal to a half times du. So now we've got this expression where we're going to integrate u to the power of 5 times a half with respect to the variable u. So basically it's integration, but instead of using x's, we're now talking about u's. So let's integrate u to the power of 5. We add 1 to the power to get u to the power of 6 over 6. We've still got that times half, which is not going to change anything. But now we plus our constant c. So we've just integrated using u as our variable instead of x. Now the final thing to tidy up is we just go top times top to get u to the power of 6 and bottom times bottom to get 12. We've still got our plus c. And don't forget, because at the start we said u is equal to 2x minus 1, we're going to replace that back with 2x minus 1. So our final answer is going to be bracket 2x minus 1 to the power of 6, all divided by 12 plus c. Right, interesting technique. And one we're going to have to practice again. So let's get into a second example. Let's go. Example 2. Integrate 2x bracket x squared minus 1 bracket cubed with respect to x. So over on the side, we're going to let u equal to x squared minus 1. We're going to differentiate that with respect to x to get 2x. We're going to multiply by dx on both sides and divide both sides by that to get dx is equal to du over 2x. Now, going back to the original working, this is what we're going to do to start with. We're going to replace the u, the x squared minus 1, with u. Now we're going to replace the dx and change that into, this is why it's called substitution. We'll substitute that for dx over du over 2x. Right, so we're going to integrate 2x times u cubed times du over 2x. Now we're just going to bring the 2x out the front with the 2x, and notice these are going to cancel. And that's going to leave us with u cubed du. So we're going to integrate u cubed with respect to u. So we've replaced all the x's with u's and got it down to a very simple thing to do. So let's add 1 to the power and divide by 4 plus our constant c and go back and replace u with x squared minus 1. Cool. Thank you very much for watching.